welcome back to Josh Does Math. In this video, we're going to be finding the derivative of a function by using the limit definition of the derivative. So this is the definition of the derivative. F prime of x is equal to the limit as h goes to 0 on f of x plus h minus f of x all over h. So that's the definition of a derivative that we're going to be using. And as you can see, we're given our function up here. So we got to find the derivative of it. So I'm just going to write out f prime of x is equal to, we're taking the limit as h goes to 0 of this right here. So for the first term, we're evaluating the function at x plus h. So that means I'm just writing out the function, but for every x in the function, I'm putting in x plus h. So it's x plus h all over x plus h plus 1. And for the second term in the numerator here, it's just the plain old function. So just writing out the plain old function. There we go. And in the denominator, I just have h. So now let's see if I try to solve this limit using direct substitution, what happens. In the numerator, this simplifies down to x over x plus 1. That minus x over x plus 1 is just 0. What about denominator? Well, that's also 0. So I get 0 over 0. That's indeterminate. It doesn't tell me what the limit evaluates to. It doesn't give me any useful information. So our goal is to rearrange this using algebra so that I don't get 0 over 0. Okay, so how do I do that? If you see fractions in the numerator, it's a good indication that you should be looking for common denominators. That might help simplify things. So just looking between this denominator and this denominator, it looks like the common denominator. This is definitely a common denominator. X plus 1 times x plus h plus 1. So that's going to be a common denominator. It's just the product of the two different denominators. So our goal is for each of those denominators up here to be the same, equal to this. Okay, so here's how you do that. Limit as h goes to 0 of, I'm going to multiply this first term on the top and bottom by this factor right here. X plus 1, x plus 1. And in the denominator, it already has this second factor right here. So we're good. It's got the right denominator. And the numerator, it already had x plus h. Okay? How about the second one? As you can see, it's got this factor already. I got to multiply by this on the top and bottom then. All right, let's do it. X plus h plus 1. All over, this is going to be x plus 1 times x plus h plus 1. So now this looks like a mess, like we might be going backwards with our progress, but we're not, because since these two denominators match, you can factor them out, and we can move them down here with h, just so that now we have a single fraction. We don't have a fraction within a fraction. So I'll write that out. Limit as h goes to 0 of, I'll move those down here right away, x plus 1 times x plus h plus 1 times h. And this is going to be over, or that's going to be the denominator for x plus 1 times x plus h minus, I'm going to distribute this out right now, x squared plus xh plus x, and I still need to distribute that negative out. So I can actually do that right now too. It's just going to make all of these terms have a negative on the front of them. So there we go. And this still isn't simplified enough. If I were to plug in 0 for h and try to solve the limit that way, I'd still be getting 0 over 0. So what I'm going to do to try to simplify it a little more is perform this distribution here at the beginning. So that's just going to be FOIL. So this becomes x squared plus xh plus x plus h. And I'm just tacking on whatever was left after that. That's this part here. That's all over h times x plus 1 times x plus h plus 1. So at this point, we've got some stuff that's going to cancel in the numerator. So I'll just cross those out right here so we can see it explicitly. So that's x squared and negative x squared. Those cancel. Okay, so get rid of them. And now we've got x and negative x. Well, those cancel, so let's get rid of them. Oh, we also got x plus h and negative x plus h. So let's cancel them out too. And the only thing we have left in the numerator is just plain old h. And we also have it in the denominator. Oh, okay, so we can cancel those out. So pretty much the whole thing is scribbled out right here. We barely have anything left. Limit as h goes to 0 on 1 over, and it's just our same old common denominator that we had before. So how about if I plug in 0 for h right now? Let's see if we get 0 over 0, or if we actually get something useful. Okay, so this is going to be, if I plug in 0 for h, I'm left with 1 over x plus 1 times x plus 1, which that's just something times the same something, so you can rewrite that as 1 over x plus 1 squared. And that's the final answer. That's what our derivative is equal to. And we found that just by using the definition of a derivative and plugging in the function at x plus h, and that's how we got our final answer. Thanks for watching.